When you think about AI right now, what probably comes to mind are chatbots, right? They're amazing artists, incredible writers. But what if I told you that what we're all seeing is really just one half of a mind? We're going to dive into the next wave of AI, one that's trying to build a complete, well-rounded intelligence. For like decades, the whole field of AI has been kind of split down the middle into two totally different camps. On one side, you have neural AI, which I like to call the artist. This is all your deep learning, your intuition, your pattern matching. It's the magic behind things like ChatGPT. And on the other side, you've got symbolic AI, the logician. This is more like old school programming. Everything is structured, based on rules, and powered by pure, cold logic. And this really hammers home the difference. Neural nets are fantastic at fuzzy stuff, like spotting a face in a crowd. Symbolic systems, they're masters of strict logic. The kind of thing that runs global finance or executes a piece of code perfectly every single time. Here's the catch, though. The AI superstars we have today, they're almost all artists. And that very one-sided approach is really starting to show its cracks. So that brings us to the core of the problem here. These AIs we have now are phenomenal mimics, but sometimes that intelligence is more of an illusion. When you rely only on pattern matching without any real logical foundation, you get a system that's incredibly powerful, sure, but also surprisingly brittle. Researchers have this fantastic and kind of funny way of describing what's going on inside these models. They say the knowledge is fractured and entangled. Basically, it's like a plate of spaghetti. You see, a person understands that a cat has whiskers and a tail and they're connected to its body. A neural net just learns a chaotic mess of features that often appear together. It doesn't actually understand the world. It just gets scarily good at predicting what word or what pixels should come next. Okay, so you might be thinking, is this just a theory? Well, no. There was this incredible study from researchers at MIT and Harvard that put this to the test. They fed an AI a bunch of data on how planets move, and they hoped it would discover Newton's laws of gravity. But it didn't. Not even close. Instead, it learned a cheat. Instead of figuring out the simple, beautiful, elegant law of gravity, the AI came up with this monstrosity, a ridiculously complex, wiggly function. It was a mathematical nightmare that just happened to connect the dots for the specific data it was trained on, but it completely missed the deeper universal truth. It was a brilliant fake, but it wasn't real understanding. And that right there is the fundamental weakness of relying only on the artist brain. So how do we fix this? What's the path forward? Well, the answer isn't to get rid of the artist. The answer is to build a bridge. It's to forge a whole new kind of mind that combines the raw power of intuition with the rigor of logic. And this is the promise of what's called neurosymbolic AI. Neurosymbolic AI, or NESI for short, is exactly what it sounds like. It's a hybrid. It's about getting the artist and the logician to work together. The idea is to create systems that can see and hear and perceive the world using neural networks, but then reason about what they're seeing using structured, logical frameworks. This makes them way more powerful, sure, but also more transparent and a whole lot more trustworthy. And as Professor Lewis Lamb puts it so well, this is about getting past that old rivalry between the two camps. It's not about one side winning, it's about synergy. It's about making both deep learning and symbolic systems better together. Okay, so that's the what. But how do you actually build one of these things? It turns out you need a whole new kind of foundation, an infrastructure that's literally built for trust. And it all starts with organizing information in a way that a machine can actually understand and reason about. The first piece of the puzzle is something called a knowledge graph. So instead of that messy plate of spaghetti we talked about, picture a super clean, perfectly organized map of the world. It's made of entities, things like drugs, diseases, genes, and the relationships between them are explicitly defined, like treats or causes or interacts with. And look, this isn't just some abstract idea. We've got real tools being built for this right now. Frameworks like this one, PyReason, are designed to take what a machine learning model sees and turn it into logical facts. But here's the cool part.
It uses temporal logic, which means the AI doesn't just know what's true, it understands how things change over time.
But, a map is pretty useless if you don't have a legend, right? That's what an ontology is. It's like a formal dictionary for that knowledge graph. It defines exactly what words like customer or product or disease actually mean, so that every part of the system and every person using it is speaking the exact same language. No ambiguity.
So, what's the big payoff for all this extra work, all this structure? How about this? A ridiculous leap in accuracy. One recent system using this approach was tested on pulling drug side effect data. The result? Over 99.9% accuracy. So all those AI hallucinations we hear about, they basically just disappear.
And this is where it gets really exciting. This isn't just about avoiding errors or getting facts right. It's about making brand new discoveries. When you can reason over these huge networks of structured knowledge, you can find connections that a human being would probably never spot. Let me show you a really mind-blowing example. So, researchers built this enormous biomedical knowledge graph and used it to hunt for existing, already proved drugs that could maybe be repurposed to treat Alzheimer's. And the results were just wow. The system flagged several drugs, including, of all things, loperamide, an anti-diarrhea medicine, and a bunch of blood pressure drugs. It was able to find these hidden biological pathways connecting these drugs to Alzheimer's that we just hadn't seen before.
Okay, so we've built an AI with a logical brain. Now what? Well, let's give it hands. Let's let it do things in the world. When you give this new kind of integrated intelligence the ability to act, you get the next giant leap in AI. Autonomous agents. Frameworks like this one, Koala, are essentially the blueprint for these agents. They bring everything together: a reasoning engine, different kinds of memory, and, crucially, the ability to take actions in a digital or even physical environment. It gives the AI what you might call agency, the ability to act on its own to get things done. So how does an agent actually think? Well, it runs on this constant loop. First, it proposes some possible actions. What could I do next? Then it evaluates those options. Which of these is the best move? It selects the winner, and then it executes that action. It does the thing. And then it observes what happened, learns from it, and the whole cycle starts over, getting smarter each time. And this space is just moving at lightning speed. The next generation of these systems is already using multiple agents that actually work together as a team. For example, a new system called Graph Counselor uses a whole multi-agent team just to retrieve information. And it's already showing up to a 24% performance jump over what we had before. So where is all of this going? What's the grand vision here? Well, the ultimate goal isn't just about building smarter tools. It's about creating an entirely new engine for scientific discovery. Some of the leading minds in the field think that if we combine these powerful models with this kind of open-ended learning, it could set off what they call a Cambrian explosion of new AI abilities, a state of just endless creative self-improvement, where the AI constantly finds new things and builds on them forever. And that really leaves us with the big question, doesn't it? By finally bridging that gap between the artist and the logician, between raw intuition and formal reason, are we just building a better, more reliable tool? Or are we on the verge of creating something else entirely, a true partner in our shared human quest for knowledge? The answer to that is going to define everything that comes next.